Imagine, just for a second, sitting down in a car with absolutely no one behind the steering wheel. You buckle up, sit back, and the car just starts moving. It confidently stops at red lights, expertly dodges pedestrians stepping into the crosswalk, and smoothly merges on a busy highway to take you safely right to your destination. Now, a few decades ago, this whole scenario, it sounded like pure science fiction, something straight out of a movie. But today, well, millions of self-driving miles have already been completed on the very same streets you and I drive on every single day.
It really makes you wonder, doesn't it? How did we actually get here? How did we transition from this distant pie-in-the-sky futuristic dream to the incredibly complex artificial intelligence that's actively powering today's autonomous vehicles? In this explainer, we're going to unpack the fascinating story of self-driving cars. We'll explore the monumental technological journey that took human imagination and turned it into an AI-powered reality.
Okay, let's dive into this. We're going to travel through 5 distinct eras today. The early autonomous dream, the DARPA turning point, the 2 dominant AI approaches of sensors versus data, the roadblocks to full autonomy, and finally, the future of transportation.
Section 1, the early autonomous dream, where it all begins. Now, what might completely surprise you is that the idea of a driverless car wasn't cooked up in modern Silicon Valley. It's actually nearly a century old. Back in the 1920s and 30s, inventors were already dreaming up roads packed with automated vehicles. Newspapers were actively predicting a future where cars drove themselves. By 1939 at the New York World's Fair, there was this incredible exhibit called Futurama that showed off a sweeping, majestic vision of automated highways. The public was totally captivated. But the technology just didn't exist yet to actually make it happen. The dream essentially stalled out for decades, until researchers finally started turning sci-fi into reality in the 1980s.
And that brings us to a truly pivotal figure, Ernst Dickmann. He's a German engineer who's widely considered the father of autonomous driving. In the 1980s, scientists were tinkering with experimental vehicles, but Dickmann's project, it was a massive leap forward. He successfully got cars to detect lane markings and actually make steering decisions completely on their own, using basic computer systems and cameras. I mean, this was absolutely revolutionary. For the very first time, a car used computer vision to literally see the physical road and react without a human turning the wheel. The foundation was officially poured.
But there was still a massive barrier. For decades, and even during those early 80s experiments, computers were just way too large, far too slow, and wildly expensive. Humanity clearly had the dream, we even had the early engineering concepts down. But the missing piece? Artificial intelligence. We desperately needed systems capable of processing immense amounts of visual data in real time, and the hardware just wasn't there yet.
Let's move to Section 2 and see how this builds. The DARPA turning point.
So, our timeline jumps to the year 2004. This is when the U.S. government stepped in and effectively changed automotive history. The Defense Advanced Research Projects Agency, better known as DARPA, wanted to kick autonomous tech into high gear, so they announced a very public competition. The challenge was simple to explain but brutally difficult to execute. Build a vehicle capable of navigating itself across a rugged, totally unmapped desert course, entirely autonomously. No remote controls, zero human intervention, just the machine versus the desert.
Now, what's really interesting about this is how they motivated the smartest minds in the country. DARPA slapped a massive $1 million prize on the table. The stakes were incredibly high. But here's the fascinating and honestly kind of comical part. In that initial 2004 competition, every single team failed miserably. Vehicles crashed straight into rocks, drove right into bushes, or literally just got stuck a few feet from the starting line. Not a single vehicle completed the course.
But you know, failure is a fantastic catalyst for innovation. DARPA came right back the very next year, in 2005, with an even bigger challenge. And the turnaround? Staggering. From 0 completions in 2004 to several successful finishers in 2005. In just 12 months, teams completely overhauled their systems, integrating much better sensors and early machine learning algorithms. This one single competition suddenly proved to the entire world that autonomous vehicles were actually possible. In fact, many of the engineers who competed in the desert that day went on to become the very leaders who birthed the modern self-driving industry.
Section 3. 2 approaches. Sensors versus data. The corporate race begins.
Following the huge success of DARPA, a massive corporate race kicked off. The first major push came from tech giant Google in 2009. They launched a highly secret self-driving car project, strategically scooping up the top engineers straight out of those desert competitions. Their goal was incredibly ambitious: create a car that could drive safer than human beings. Over the years, this project, which eventually spun out into the company we now know as Waymo, completed millions of miles on public roads. They proved that self-driving tech wasn't just a quirky desert experiment anymore.
And this brilliantly illustrates the two highly debated philosophies that emerged as the smartest minds tackled this problem. On one side, you have Waymo. Their approach heavily outfits vehicles with an array of expensive hardware. We're talking highly detailed pre-programmed maps, multiple cameras, radar, and complex laser sensors called LiDAR. They want the car to have a perfect 3D mapped understanding of its environment at all times. On the flip side, you have Tesla, led by Elon Musk. Tesla's approach completely bucks that heavy sensor philosophy. Instead, they rely almost entirely on computer vision, using standard cameras to see the road just like our human eyes do, and they pair that with massive amounts of crowdsourced driving data to train their AI.
Tesla's unique data loop is pretty brilliant, and it works like this. First, hundreds of thousands of customer-owned vehicles are continuously collecting driving data from real roads as people just go about their daily commutes. Second, all of this massive real-world data is fed back to supercomputers to train the AI system. And third, through this continuous exposure, the AI actively learns to recognize cars, pedestrians, traffic lights, and completely random obstacles. The more data they gobble up, the smarter the AI gets. Millions of drivers are unknowingly helping to train one of the world's largest autonomous driving systems simply by going to the grocery store.
Which brings us to Section 4, Roadblocks to Full Autonomy.
Despite all this incredible processing power and millions of miles of data, the road to a completely driverless world is, well, it's bumpy. There are serious physical and regulatory hurdles we're wrestling with right now. From a purely technical standpoint, bad weather, like heavy rain, fog, or snow, can easily confuse even the most advanced sensors and cameras. AI also really struggles with highly unexpected road situations or the unpredictable, sometimes completely irrational behavior of human drivers. And then there are the bureaucratic hurdles. We're talking strict safety regulations that vary wildly from city to city and a massive web of legal complexities.
Which brings up one of the most debated ethical and legal dilemmas of our time. I want you to really think about this for a second. If a completely self-driving car causes an accident, who is actually responsible? Is it the human sitting in the driver's seat who wasn't paying attention? Is it the manufacturer who built the physical car? Or is it the AI system and the software engineers who wrote the code? Governments, insurance companies, and tech giants around the world are still actively scrambling to find the definitive answer to this question. Finally, Section 5, the future of transportation. Where do we go from here?
We have to remember that this isn't just a theoretical debate happening in some closed-off laboratory anymore. Today, right now, autonomous taxis, completely driverless vehicles without a human safety driver, are already operating and picking up paying customers in several major cities. The artificial intelligence powering them is growing exponentially more powerful every single year. The infrastructure for this future is actively being laid down as we speak.
And the ultimate promise of this technology? It's staggering. We are looking at a future where self-driving cars continuously communicate with each other on the road, anticipating movements before they even happen. This could lead to drastically reduced traffic congestion because cars would just optimize routes globally. It promises a massive prevention of accidents, potentially saving countless lives that are currently lost to human error, drunk driving, or fatigue. It represents a complete and total transformation of how human beings move across the Earth.
So, the crucial point is this. While experts are absolutely going to continue debating the exact timeline, with some saying full everywhere autonomy is a decade away and others saying it's going to take much longer, the 1920s sci-fi dream of a driverless future is no longer just imagination. It is actively being built today. The code is being written, the real-world data is being gathered, and the cars are already out there on the road.
From those early, dusty newspaper predictions to a highly complex AI-powered reality, this is undoubtedly one of humanity's greatest technological journeys. And the truth is, this journey is really only just beginning. The technology will inevitably arrive at our doorsteps. The only question left is, are you ready for artificial intelligence to take the wheel? Thank you so much for joining me on this explainer. If you found this dive into the evolution of self-driving AI as fascinating as I did, keep exploring, keep learning, and I'll see you next time as we break down another incredible topic.